Welcome everybody to 52 Living Ideas. This is the Bucky Inspired series that we do in collaboration with the Greater Philadelphia Thinking Society. I am honored to have Don Briddell here. He is the brain, he is the motivation behind the Fieldstructure Institute. And I am really honored to have him present. He's talking about a new kind of geometry. And I will let him, he's going to do a presentation. It's quite a bit of material. Keep track of all the questions that you have. There'll be plenty of time to ask those questions. Keep track of questions and comments. Once the presentation is done, we will go ahead to questions and comments. So welcome, Don. Let's get started. Go ahead.
All right, I'll do the share screen. These ideas that I'm going to be putting out here really start with very basic things, and I find that I like because it obeys the Okram's rule that the simplest explanation is the best. Now, you might not think this is simple as we go along, but it pretty much is when you consider what's the basic form that's generating all of this material. So this is kind of a symbol that I use that says it all for me. So what I'm going to be doing is reading through these things and showing slides of pieces. And I also have on my table here an array of the different pieces that I can pick up and show you if we need to look at them more closely. Okay, so we'll start with an introductory note here that if you wish to discuss a point, jot it down and we'll do a Q&A at the end as Shrikant suggested. Also, it's important to understand the scales that I'm using to be clear, because there's ambiguity here in general. So the N scale, as I call it, is 10 to the minus 16 to 10 to the minus 34. And that gets you down to the Planck's constant. Planck's constant is the most minimal unit of action that we've found in the universe. We've never found a half of a Planck's constant. And it seems to work perfectly with quantifying larger scale events. So the micro scale is 10 to the 6, which is 10 to the 6 is the size of a cell, like an egg, and 10 to the 16 gets us down to the level of particles. So macro scale is the one that we're familiar with in our daily life, and it's 10 to the minus 5 to 10 to the plus 5. The cosmic scale goes from 10 to the plus to the 6th power and 10 to the 35th. And then unity scale, this is sort of my idea here. I haven't run across this anywhere, but I like it. It's 10 to the 36 to 10 to the 64th. That because not only is there a minimum energy event in our universe, I believe there's also a maximum energy event, and that's 10 to the 64th power. Okay, so those are scales. So the topic today is tometry. This is a new geometry, and I want to advise a listener that I can't confine the topic to geometry. Tometry and the natural world are inexplicably linked. Often words used to discuss objects or processes in nature, in physics and chemistry, are sometimes better at describing issues than a geometric term or a tometry term. So I will be moving back and forth between tometry and words used in physics. There's another issue found throughout this paper for which I must apologize, and that's what appears to be my claim of originality. Presenting new material is always troublesome. I felt it was helpful to the reader or listener to know where things are coming from, even though it sounds bombastic in self-glorification to proclaim originality. I do that to alert the listener that there's something new being offered. For that, I apologize. I haven't found another way of speaking about these items without introducing confusion. So new ideas sometimes need new words, and we were just talking about that with Shrikant. And I wish I didn't have to do that, but in the long run, it will avoid confusion. What I can tell you is that all the important ideas in this paper are what I call downloads. I am simply not smart enough to figure this stuff out myself. What I'm good at is listening and asking the cosmos incessant questions and holding them, and I'll let it go at that. Looking around at physics, the guiding principle that the universe is structurally scalable has been missing. In other words, there isn't an idea that can consistently and quantitatively go from the smallest event to the largest event in the universe. And this is the problem physics has, and it has no solution as yet. So this is my offering on that. Now to begin, prior to Tometry, there has not been a geometry that could operably account for fundamental structure, nor has no one has known the particles or what energy and particles look like. It has been a speculation. I have come to accept that without the correct geometry, present theories in physics are not scalable. I developed Tometry to correct that problem. It wasn't that science isn't interested in scalability, they are. The problem has been they had no analytic that could be scaled. Science began by trying to reduce in scale macro-sized forms of common experience, taking what they knew about macro structure with them into the micro scale. Physics has gone from cells to molecules to atoms and now to particles. And each scale needed fewer and fewer parts. With parts, it got down to 3 stable particles: the neutrino, the electron, and the proton. The neutron is a compilation of all those 3, but it's only found in the nucleus. And out of the nucleus, it decays into those 3. So in the beginning, Stanley Wasaki, who was my thesis partner at Pratt, and I looked for fundamental structure in a similar way with form and structure theory. This led us to a new geometry, to what's now called Tometry. Its assumptions are the opposite of Euclidean geometry. Euclidean geometry makes the following assumptions. Lines intersect. Lines have no dimensions, they're infinitely thin, and lines have beginning and endings. And there is no mention made in these assumptions about structure. Euclidean geometry is all about form, idealized form. They considered it perfection. Tometry became necessary to understand not only form, but structure as well. I didn't set out in my study of form and structure to create a new geometry. It became apparent that my work with material form and structure was not obeying the assumptions that Euclidean geometry was making. Euclidean geometry has been used by science ever since Euclid, although it has been augmented to do new things. Each augmentation carried along the original assumptions I just outlined. Nature, with its natural constraints, only supports forms that are structurally meaningful. Mathematics is not so constrained, and that's the problem. Math's glory is that it can describe anything, but nature is not anything. It is highly constrained. So I go by this statement. What is needed is a geometry where the allowable forms correspond to the forms allowed by nature and no other. This is what Tometry does. This makes an analytic that is derived from natural objects a safe and self-proofing analytic. The natural world is neither an analogy or a metaphor. It is pure, sweet reality and nothing more or less. The problem with mathematics, as we know it, is that the mathematician uses analogies and metaphors and symbols to describe reality. What if we had a way of modeling reality that worked directly with nature at our macro scale without using symbolic stand-in language of mathematics and was adequate to describe micro, macro, and cosmic structure quantitatively? And quantitatively is the key word here. That was the question Stanley and I asked. That meant we didn't study mathematics, but instead we went directly to natural forms and structures without any interface between us and the structural principles we sought. In doing that, we discovered eventually that the right structural system, with the right structural system, we could iterate down fractally to work with models that had the same structure as smaller or larger scales of reality. These structures were called field structures. With them, and for the first time, forms delineated the structure of field energy. This was new in geometry, a form and structure theory, in form and structure theory and in physics. Prior to field structure models, there has been no way physics could model a field except mathematically, using such things as scalar or tensor field maps. Field structures are more than maps. They reveal the underlying structure of forms as we see them, as we will see. Physics has not had such a thing previously. It is now possible to describe a field on your kitchen table with tools and materials found in a hardware store. This will undoubtedly be disturbing to the engineers and theoreticians at CERN, the Large Hadron Collider, who are trying to do the same thing, spending billions to build the machine and billions a year to maintain it. Structural analytics gets us back to working directly with nature. When science adopted the mindset of Euclidean geometry created 2,500 years ago, it did so with the prevailing understanding of the times, which was that reality was Earth-centric. It was a math based on terrestrial experience, and that is why we have problems today in physics. Physics is now extending investigations into the micro and cosmic scales of experience, and they need a tool to do that. These words are different than what our Greek ancestors understood as being real. The Greeks developed Euclidean geometry to deal with their terrestrial-based experience. It is in the seen world of the macro scale that our views of form and structure were formed. The analytic used in science today have followed faithfully the 2,500-year-old Euclidean paradigm with only modest modifications. The DNA of Euclidean geometry continues to program the thinking in physics today, in spite of Newton and Einstein's modification to the Euclidean mindset. Einstein only tweaked Euclidean ideas, even though his tweaks had profound implications. The new geometries invented by Newton and Minkowski, who taught mathematics to Einstein, and others are, in my opinion, extensions of the Euclidean mindset. In other words, they're still using those assumptions that I mentioned previously. It has led inexorably to startling, if not shocking, conclusions about our world. We are in the modern period where reality is thought to be governed by uncertainty, probabilities, and chance, something the Greeks would be horrified to imagine. How could this happen to Euclidean's perfectly tuned geometric world of congruence? For me, the structural analytic of Tometry solves that problem caused by using Euclidean geometries and its curved spaces descendants. With Tometry, the structural analytics we have, at last, a fractal topological skew analytic that can give us understanding of where and how the mass and energy values of particles appear. Something probability mathematics has been unable to do in a deterministic way, I should say. And doing that has given us the multiple certainty principle that replaces indeterminacy with a new form of determinism. And this the uncertainty principle is the bedrock of quantum mechanics and modern physics. And so, but I'm leaping ahead in the discussion. Science has given us an excellent description of natural phenomena, for which we are thankful. Science has done this for us spectacularly, and yet it hasn't given us the tool to unify reality into a single, all-encompassing idea, a unified field theory, or as others ambitiously called it, a theory of everything. What is needed now is an explanation that justifies the empirical data. Einstein, who died in 1955, did not live long enough to be aware of important discoveries needed before a theory of form and structure could be accomplished, namely developments in physics and mathematics made since Einstein's time, such as synergetics, fractal geometry, cellular automata, and particle discoveries, among other things, and most recently, three-dimensional space-time knot structures, field structures they're called, and Tometry that underlies this thinking. In many things, it may be a good idea to be gifted and talented mathematically, but for theoretical physics, it has been a box with no windows. As Richard Feynman pointed out, and he's a Nobel laureate physicist, very famous in the world of physics, said, and I paraphrase, mathematics is not the same as nature, meaning mathematics did not come first, nature did. Mathematics is a language, and a language is a device used to describe something. Mathematics is a step or two or three away from natural form and structure. Mathematics, now here's the real point here. Mathematics depends on its user to supply the meaning as to what numbers, operators, and symbols of math mean. This is problematic because it is not direct. It relies on conjecture and the interpretation given to it by the mathematician. So the mathematician is in the way of nature. He's put himself in front of nature, and he's not experiencing nature directly by the outcomes. So if mathematics doesn't have the proper understanding of natural structure, the math will be unlikely to render a meaningful model of nature, free of possible distortion. Physics tells the math what they expect it to happen. Nature speaks with reality. Physics speaks with theory. Okay, I'll be getting to the model shortly here. I just have to set the stage for this material that's coming up and to explain why it is that all of this work was not inspired by mathematics, but by working directly with nature.
Don, this is going extremely well. Everything is very clear. Please go on.
Oh, okay. So far, what theoretical physics wants nature to say is not happening. Nature is already organized It is the physicists who haven't synchronized with nature's organization. Physicist Sabine Hassenfelter, in her book Lost in Math, she's a physicist, a German physicist, has explained some of the problems with mathematical physics. And if you're interested, I suggest her book. Also, physicists Peter Wout in New York and Lee Smolin in the Perimeter Institute in Canada have written about the problems physics are in. And these are deep existential problems for physics. And they're complaining there's no way out, and the people that are holding the present paradigm are not letting evolution occur because they're holding on to their ideas. So the pure mathematician is not tied to nature and has stated they have no desire to be constrained by nature. That's the pure mathematician. That's their view. Physics, however, is supposed to be constrained by nature, but uses math that is inherently unfettered to nature to do the constraining. We can see a problem. Structural physics does not do this. Rather, it confines itself to a natural analytic and assumes the math will come later, as it did with Buckminster Fuller and others down through history. Pure nature and mathematics are not the same thing, and mathematicians agree. Field structure theory considers a structural model to be an equation. For the structuralist, the model must have the potential to achieve holism. Furthermore, and importantly, the accounting must approach the ideal of Occam's razor, which insists the simplest explanation is the better one. Nature, it appears, is astoundingly simple, finding that simplicity is everybody's goal. Presently, modern physics is tantalizingly close to that goal in some respects, and light years away in others. The derivation of the word tometry may be of interest. Geometry alludes to a mindset of thinking geo, referring to earth, and metry, to measure, earth measure. 2,500 years later in our time, we need a cosmic measure that can scale from Planck's dimensions to the universe in its entirety. So now these are tometry's assumptions that contrast to Euclidean assumptions. Lines delineate action. Tometry is a structural analytic. That's what it's interested in. Lines interact, they do not intersect. Lines have dimension, they are not infinitesimally small. Lines never end. Euclidean lines have beginnings and endings. Lines are loops. Stanley and I were inspired mainly by William Catavlas, our thesis advisor, Buckminster Fuller, and Kenneth Snelson, all of these we met. Field structure theory was at the time just a vague idea limited to Euclidean geometries of various kinds. So at the beginning of our thesis, Stanley and I looked at the world and its describable diversity and said, how are we going to unify with a comprehensive theory the plethora of forms there are in this universe? We thought this might be mission impossible. Being young and foolish, we decided, if not now, when? And if not us, who? From the start, we realized we lived in a 3D world. So what we do has to work three-dimensionally. 1D and 2D are useful as thumbnail notations, but they have to be scaled up to 3D to be real. Having extra dimensions changes everything. Fuller had proclaimed that the triangle and tetrahedron, I call it TNT, were the only stable forms in nature. And there are many references to that in his book. Along the way, the realization dawned on us that in nature, TNT forms are actually rare, especially in micro and cosmic scales. There doesn't seem to be any TNT forms. I later came to the conclusion that TNT assumptions was correct for the plenum. But in relative world field structures, TNT was how nature structured reality. That's at our scale. The difference is the plenum is an absolute structural matrix, whereas manifestations of form derived from the plenum are dualistic and relative. What then was holding things together at either end of the empirical structural continuum, i.e. our universe? What's holding this universe together? The question haunted us. Outside the macro scale, Fuller's TNT ideas didn't seem to be what was working. So I've made presentations to learning groups at various universities around the country and in Europe. And the first thing I do is hold up these two forms and ask which is stable. And to my absolute amazement, so often the scientists I'm addressing have to think about it. Some get it right away, but I'm telling you, the majority have to think about this, which shows a complete lack of structural understanding. To me, it does. So as we can see, it is the square that is not stable. These are hinged, little hinges. So these sticks can move independently if they could. And they can't as a triangle, but as a cube, they can move, and this is what can happen. And we just hope you don't live in that form. Now we see that the cube does not have a stable structure. How does nature make a square stable? Humans add interior triangles or triangulates the perimeter and do things like that. They have to introduce the triangle or the tetrahedron to make anything stable. Turns out nature has two ways to make form structural. It can triangulate by doubling a form to make it rigid. So the cube, if you put another cube in it, what you do is you end up triangulating the form, and this becomes rigid. And here's a five-sided form, same thing happens. But without introducing the other chiral counterpart to that form, it no longer is stable. And this is these are made with two different loops, the yellow loop and the white loop. This is a seven-sided form that's one loop, and this too is stable. So by adding a connectivity to all the points in the form is the way nature sets up and makes fields. The other way is this way, that instead of doubling the square, as I did here, I circuit the square with these loops. And this is one loop. And this form is very structural, but it does wonderful things because you can spread that square apart and it will remain. If you take two sides of that and pull those sticks apart, the other sticks will adjust exactly to it. So now this is the way fields work. Fields always are after equilibrium and stasis, and forms sustain themselves because they achieve that necessity of a field to equalize the energy throughout the system. So no one part of the system has more energy than the other part. And it does that by creating field lines around forms. So above are two ways nature structures form. Nature needs these two ways of structuring, as field structure theory reveals. A micro scale building is structural only to the extent it employs TNT. But at the micro scale, we don't build with field structures. We build with this kind of structure. and we haven't got to the point where we can build a building that's held together by its field. That will come. We build a micro scale structure by triangulating, a subject well covered by Fuller and his friends. In the micro and cosmic scales, nature builds with fields and doesn't use TNT per se. I got to say per se because there's a qualification here that will come up later. Actually, nature builds everything with including TNT with fields. Even a triangle or a tetrahedron is really a set of little fields that are being linked together. Why would the macro scale forms need the support of TNT and not the micro and cosmic scale forms? Actually, it is the plenum that supplies the support. The plenum is an absolute tetrahedral action matrix. So TNT is latent in all forms. This is confusing in view of item 106 that I just mentioned, requiring a paradox to resolve that. Paradox is what happens when the absolute and the dialectic relative intersect. I'm writing a book to explain what happened in our thinking when awareness of fields gave us our first look at how the modern age will be powered, thanks to Michael Faraday, who in 1850, thereabouts, discovered field force. Okay, so Stanley and I discovered the field structures in 1965 at Pratt. At the time, we called them torsion structures because torsion was the force that stabilized the polyhedra in 3 dimensions. We were not studying physics at that time, so its application to physics waited until after we graduated. The idea of recognizing tometry as a geometry began forming in 1970. We completed our senior thesis in 1966, just as the Vietnam War got ballistic and had to face the draft. Stanley enlisted and fortunately never left New York. I wanted to continue my work and got a full scholarship at Illinois Institute of Technology, but my draft board said I had to go in the Army. I asked if I could join the Peace Corps and was given a deferment, meaning I could be drafted after serving 2 years in the Peace Corps. I mention these things because it is important to the development of tometry that I had 2.5 years to think about this in the Ecuadorian Andes while working in small industry development. That period away from the compression of New York City to be up in those mountains and was just necessary to start sorting things out. Hold on, let me get rid of that yellow. Okay. So it was during this time I began to study everything I could find on what physics had to say about the structure of the universe and fields. It was physics concern with fields that became the center of attention in my work in 1971 while working in South Africa. The unified field theory was attempting to see the world as energy fields. By different means, structural fields became my path forward. The problem was there's no geometry that could describe a field in a way that could explain matter and energy as states of the same thing. They were dealing with fields mathematically and not structurally. The behavior of particles, objects with mass, in a field had been well studied. What field structure was itself remained a mystery. Nobel Prize winner Richard Feynman famously said, "It is important to realize that in physics today, we have no knowledge of what energy is." And that statement really knocked me over when I read that, because the universe is nothing but energy. And yet we have no knowledge of what that energy is. And this is a top line physicist talking here. So particles and atoms are like cars on a road. The car follows the road, the field. But why the road dips and bends and curves remains a mystery. The idea physics was pursuing was that the car created the road. And if you look into quantum mechanics, you realize this is what's happening. Where a car went was determined by the particle's energy. The particle determined the path it would take. This raises red flags all over the place for a structuralist. The road must have a reason for doing what it did, independent of the car. If the car had its way, all roads would be flat and straight. This is what physics has been stubbornly trying to do, make a theory fit their ideas of how it should be. And mathematics is the best way to do that. Physics says 1 + 1 = 2. What if nature was saying 1 + 1 = 1? Einstein saw the problem and developed the notion of field that was linked to the road, that linked the road to the car. And with that, a new insight into gravity was made. Conveniently, gravity keeps the car on the road. However, it still does not explain the structure of a gravity field. The question has been, yes, we see how gravity explains the motion of an object in a gravity field, but still, what is the structure that links the object to the field? The object is not independent of the field because the heavier the object, the deeper the field. Field and objects are linked, but how to explain this structurally? Now we're going to look closely at Tometry models and its way of analyzing form and structure to see how fields obtain and induce structure. This will explain energy and matter. The trick is to quantify the relationship between field and object. And I'm back to stating this again about what is needed in geometry, where the allowable forms correspond to the forms allowed by nature. That geometry is tometry. Bear in mind assumptions made by tometry. Lines delineate action. Tometry is structural geometry. Lines interact, they don't intersect. Lines have dimension. They are not infinitely small. Lines never end, and lines are loops. And nature always wants to relieve any stress or deformity to that loop. That too is an important qualification, and it explains what entropy is. The foundation of form of a field structure with which all higher complexities of field structure can be built, the foundational form is called a structure. So the family name is field structure and the species name is structure. The simplest form of a field structure is the Tet structure. All field structures come in two forms. Let me get rid of that. Form 1, which you're seeing here, is the Wasaki-Briddell field structure. And it's a condensed field structure. This is a stereo photograph that Joe Clinton made. And if you look between, cross your eyes and look between, that whole form becomes three-dimensional. And I'll pause for a moment to let you get that effect. Okay, stereo images. Cross your eyes, look between the two images until the third image appears, and that will be three-dimensional. So this is one form of a field structure, the condensed form, and this is the diploid form. The same three loops, red, blue, and yellow that we have here, but in a diploid form. This is a form Joe discovered. And shown here is the tetrahedron. This can be done with any polyhedra, no matter how complex. All of these forms can be any polyhedra, meaning anything in 3 dimensions can be made with loops. That is this was discovered in 65, and it took years to figure out what was really going on here. Energy is either condensing. Get rid of that. Energy is either condensing, which is this model, or deploying, which is this model. And between deployment and condensing, any movement from one to the other is the whole realm of where energy is found. And I'll be explaining that as we go along. So that's just a note. All right. Opposites attract, because the condensed wave wants to have equilibrium with the deployed wave. So here we can see that these waves are condensed because they've been twisted. If you follow one of the loops, you'll see how that loop has been twisted, which is a condensing motion. And the loop does not want to be twisted. You bend any material, it wants to go back to where it was if it has any tensile strength to it at all. Energy exists wherever there's asymmetry. So this is an asymmetry that is locked in this position and can't get out of it. These loops can't get by the other 2 loops in order to untwist. So by doing it 3-dimensionally, this form is stable. It won't explode. If you break this knot here, the form will expand, as we see here, but in a different way. So let's take a look at this. The ropes illustrate why we live in a 3-dimensional world. It takes 3 loops of action to fixate a form in space. We now have a way of explaining why we have 3-dimensional world, because we got 3 action loops interacting with itself, producing a polyhedra. You see the tetrahedron in here. So these 3 loops are producing a tetrahedron. And we'll see that these loops produce all the geometric forms. We now have in a structure, it can be seen how 3 loops produce the tetrahedron nucleus. Tometry shows how all forms in the universe have a condensed nucleus and a deployed energy field. So that's what's going on. You got condensed producing a nuclear polyhedra and a field form that is trying to radiate out, is trying to expand, but can't because it's locked itself into a knot configuration. So you've got expansion and contraction both going on to create this form. Bent loops want to unbend and become simple loop circles, but they can't. They can't unbend because they are in effect knotted together. The structure was discovered, I've said that. We also discovered that all polyhedra are 3D knots, and any polyhedra that means, that means any form in the universe can be made with knotted loops. So now we've got a geometry that can reproduce all the forms in the universe with loops. We've got a way. Now, what we've done is applied this architecture of loops, scaled it down fractally to the micro world and scaled it up to the macro world, and then scaled beyond that to the cosmic. and it's all with loops. So here, that's the tetrahedron. Here's the octahedron. And now the octahedron takes 4 loops. And the hexahedron cube takes 4 loops as well, because they're duals of each other. And then the icosahedron is this form. Get it so you can see the whole thing. I leave a little icosahedron, polyhedron in the center to kind of identify what that form is, because now we've got 6 loops that are creating this form. And if you study what a loop is doing, it's actually looping around and creating a torus. So there's 6 toruses of action interacting together to produce the icosahedron. And its dual, here we have just 1 loop to show you how it moves. Top view and a 3/4 view, and you can see the donut shape that it's taking. And the dodecahedron. Now, the difference, they both have 6 loops, but the dodecahedron requires the loop to go around twice. If you look at the blue loop, it loops around the form twice, as do all the other colors. And that's the difference between icosa and dodeca. Now, all other knots found in topology are knots in 3D space, such as this dark one here, that's a trifold, but themselves are not 3-dimensional knots because they don't create a spatial event. This is 3 loops creating a spatial event, and I call this a true 3-dimensional knot. This is a knot in space, and this is a space-producing knot of loops. Okay. For the first time, we have a way of modeling a field, and that's the goal that we set out in the beginning. Is we want to have a unified field theory, but we got to have a structural geometry that will give us that unification. And this is what we found that could do that, this system of structure. Now, notice in this structure, there's no glue, there's no fasteners in this. The only thing holding this thing together, and it's quite strong, is the fact that each loop wants to become a circle, but it's prevented from moving into a circle by 2 other loops also trying to move into circles, but in different XYZ directions. So objects exist solely with torsion force made possible by knotting loops together. Also note that the lines carry force. So this is another important aspect of these forms, is they carry force. They're not just insipid, limp little models. They're actually carrying force. And some of these, if built with wire, are actually dangerous if they come apart, because they really can carry a lot of force. Also note that the lines carrying force are torsion force. The twisting and bending needed to make a 3D form is the source of energy in the universe. So torsion is how this universe creates form out of loops. Now, we have a way of explaining how energy becomes a binding force through the agency of knotted loops carrying action or torsion. It also, to create a structure, it is necessary to create a nucleus and an energy field that goes around and through the polyhedral nucleus. So this field is actually creating the form the polyhedra. And perceptually, when we look around our room, what we're seeing are the polyhedra. We're not seeing the fields. Actually, there are some people that can see these fields. And but the fact that the field is creating the form is the fundamental thing that I don't think physics is realizing. They are trying to tell us that the form creates the field. And there is an argument for that. But when push comes to shove, what's real are the three loops. What is not real is the polyhedra, which is just an apparition created, a hologram created by these action loops. And the hologram concept is an important thing. So I've explained all of this. And I've explained the particle hierarchy paradigm in a book released maybe 2 years ago. And it gets into the nitty-gritty of how loops produce the mass and energy values that physics, they know the value, but they don't know how they're produced. This explains how they're produced. So there are higher field orders than the structure. There's superstructures. And a superstructure is the platform of atoms. The structure is the platform of particles. Particles make atoms. So structures make superstructures.
Don, may I interrupt at this point?
Yeah.
What I want to do, Don, what you're doing is really spectacular. What I want to do, and it is very fundamental, it's a way of actually looking at the world very differently. I think maybe this is a good stopping point. I would like to have you come back and do the second part separately. And I want to actually engage people at this point. Do you think this is a good stopping point, or would you like to stop? Would you like to say something to wrap it up? And then we will do part 2, maybe in a week or whenever it is convenient to you.
No, let's do what you suggest. I think it's a good idea.
Okay. So could you stop sharing? I have a couple of questions, and then I'm going to open it up for other folks. Folks, just think of questions at this point. Okay. First, what you're trying to do is that Don is saying something. You're trying to understand what he's saying. Okay. I'm trying to put my mind around it. And I honestly, it is actually quite, this is very revolutionary way of thinking about things. Okay. So I'm going to try my attempts here. And then I want you to, also think at that level. Do not compare it to other things. Okay. Just focus on nature and how Don is approaching nature. Okay. Because that's the heart of the thing. If you go back to saying, okay, this is how I'm used to thinking about it, you're already lost. You won't be able to actually understand it. And after you've understood it, you can go back to whatever you have. Okay. But first, the question is, what is it? It's like, let me just say one thing here. I like the word understanding. Okay. When you're understanding, I don't like knowledge. I like understanding. Understanding means you're standing under nature. You're realizing that you're a disciple, you are a student. You're trying to stand under it and trying to grasp what is it. And that's what you do in order to understand. Tom, so may I request one thing? Can you show us actual, just, tetrahedron is something that we have been working on. That form,
yes, yeah,
is familiar to us. Can you show us
to the center here so I can
please.
show the form? Okay. This is a working model of a structure, the simplest enclosure of space with 3 loops. And as you can see, the tetrahedron in here and how the loops are bent. And then this is Joe Clinton's deployed version of the same 3 loops. Okay. Now, what nature does is, what you see there is what is called a fermion. And it has I have to get technical here, but it has spin 1/2, whereas something that has spin 1 is electromagnetic energy, because both the clockwise and counterclockwise rotations are in that electromagnetic impulse. It's spinning both ways and it's locked together. And to show how, well, let me do this. These rope studies are really useful. And we're thinking now of, what does one loop, what can it do? And this is a single piece of string. You can see where I soldered it together. And it's wound together so that it has nodes. And so this form has frequency. And if you count the nodes, you know how many times it's twisted to create this form. So imagine this as an electromagnetic loop. And these have been made. There's a guy up in Massachusetts who I've been in touch with, and he's developed a machine that can produce these electromagnetic loops. In the first person to ever do it without a confining magnetic field. Okay, so this is a single loop. And this is a double loop. And you can see where it's welded here and here, the two different loops, and they're wound together. And I've marked one with a black line and one with a red line. Now, those are deployed loops, and they're in stasis. They're a perfect example of something that's entropically stable. And so nature starts with this, and these loops pervade the universe in all different frequencies. But what nature has done is taken a loop like this and condensed the knot. So I can get far enough away. So here is the form of a single loop with the energy condensed to what I call a nucleus. And out here, there's just one twist in this line out here. And all the other frequencies is here. So I've taken something that's stable and created an unstable situation, because this loop, if it was a kinetic electromagnetic loop, would want to race back over and go back to being in balance. But what nature does to protect the universe and to create it and make it possible is it condenses this loop, 3 of them, so that they form a polyhedra, which is a spatial event, which we need to have in the universe. All matter is a spatial event. And so what the field structure models do is take this model and put it into that form, and this is what you get. Now, if you look at the vortex here, or vertex in Euclidean speak, I call them vortexes, you see that the blue one is over top of the white one. So the blue one is twisting clockwise. If you look at that little area right in there, they're twisting the way the clock twists. And the white one is going the other way. So that's the same thing here. We've got a right and left-handed twist going on here, and you can't make these without creating both. But when you condense it, all of the right-handed or left-handed condenses, and what's left is the other one out here. So this is why the proton is a positive charge and the electron is a negative charge. And this model here shows it. But if this was an electromagnetic model, what would happen is the electron wave, which in this case is the white one. This is actually an antiparticle. But what's happening is the wave that's twisted clockwise is over top of the wave that's counterclockwise, and it cloaks it. Now we're made of real waves, real matter, we call ourselves. But whenever physics has found that whenever you create matter, you create antimatter. You can't do it without creating the other. We're in a Carroll universe here. The problem's been, well, where in the hell is the antimatter if both were created? This is where they are. That's all right here, but we can't see it because real matter waves are cloaking the energy that's twisted the other way. And what would happen is if this form was produced, it would quickly, through electromagnetics, condense the energy to the nucleus, and that's this form. And here, all of these little strings in here, they would be wrapped around out here, as in this situation, but electromagnetically, when you put them three-dimensionally, they collapse into the nucleus. So that's why the nucleus, the proton has 99.94% of the energy of an atom. And the other 0.06 is what's out here, that single twist. So that's how the energy gets stored in the nucleus.
Wow.
I mean, you can see how this is going.
Yes. So Don, look, what you're saying is very revolutionary, and I'm just trying to get the basics here. What I want is I want it to be accessible to everybody. I want the basic ideas to be accessible. I want people to have almost a feel of how this dynamics of a loop actually creates 3D things. So let's go step by step. I'll be happy to have you back, talk about more advanced things. But I myself, and I think many of the listeners of this video on YouTube are at a much lower level at this point. So I want to kind of go a little bit step by step. Is that okay with you?
Perfect.
Okay. Again, my understanding of it is very poor. I may be making many, many mistakes here when I'm asking questions. So please bear with me. Thanks to Buckminster Fuller, we've been spending a lot of time on tetrahedrons. Okay. So one thing that I want people to really get is how the three loops produce a tetrahedron. Because if they understand this, I think that is critical. You can correct me if I'm wrong. I think it is critical because it is actually showing you how a field motion, three field motions actually produce an object, because the entire mindset of people is object-based. Yeah. They say there are tables, and then let's see what is happening to tables. Exactly. But this approach is saying that, look, no, there is this movement, this interlocking movement of these three loops, which is actually creating the object. Yeah. Okay. Now that's a dramatic reversal. Okay. And if all people get from this entire video is that shift, that it's the field which is the primary and the 3D object is the secondary. If that's all they get, I think it will be a giant step forward. So I just want to focus on just that aspect. Okay. Like one of my favorite, one of my favorite thinkers and favorite architects, Louis Sullivan, he says form follows function. So his idea is that the function is these things, and whatever forms there are the things that are temporarily generated, and form ever follows the function. So I want to just get to people, and I want people to, and the good thing about this group, Don, I love these people. I love the people who are, watch the videos, and they are actually trying to understand. And one of the things that we have found is that to actually work with, these things in physical space and saying, okay, this is how it is put together. This is how it is. Now I understand how these things, actually playing with these models, making sure that is what is needed, because it is a Copernican revolution, really. You're saying that, no, these loops are fundamental. So would you be kind enough to just talk a little, just focus on the tetrahedron? Let's look at how those loops are and how they produce the stable tetrahedron. Can we spend a little bit of time on that? Do you consider what I'm asking a fair thing to ask?
Of course, yeah, absolutely fair. It might be helpful, since the group knows about Fuller.
Yes.
And understands that kind of geometry that he's working with, to show you a model that I think really illustrates what's going on here.
Please.
In geometry, you have one polyhedra, and how it connects to another polyhedra, and it's like they're face to face, and you build close packings, and you do all those kind of things, but the forms are touching. In a geodesic dome, all the triangles are touching each other. So the question that we need to ask, I feel, is, well, what about the forms that aren't touching each other? How are they controlled? Because they're, the sun and the moon and the earth all are in very controlled motions. And what's controlling those motions? Obviously the field is doing it, but how does the field do that? Now here's a model I want to show you. This is a model of a molecule. I have a tetrahedron here, which is one atom, and I have a tetrahedron over here, which is the other atom, and it's all connected by these loops. So now we have an architecture that can explain how things that are not touching are structurally stable. And what's interesting, if you study these things, instead of like the triangle here, to be by itself takes 3 loops. But when I put them into a molecular form, this is all one loop. So how come we need 3 as an atom and only 1 as a molecule? And this is actually a molecule of H2, two hydrogen atoms connected. This is a form of natural form. And the way it's stabilized, like the orientation of the tetrahedron to each other, is determined by these loops. It takes this one loop zipping around like this to make a stable structure out of this. And there turns out there are other ways of doing the same thing. This is another loop. And this one doesn't have the twist in the center the way this one has it twisted together. And the tighter you make these loops, the stronger that bond is. So now we've got a way to model nature that isn't in physical contact with each other, because we've now defined the field. And there's some interesting properties that have to go on. Like if you start with a loop, and here this red string was originally all around this loop. So the loop, the white loop and the string loop were the same size. And I was playing around with, well, how does nature condense to get this frequency in here, to get this energy condensed? and it doesn't cut this loop. The idea that the loop can be cut is a fallacy. There are no such things in nature as a loop that isn't a loop. And so what nature does, here I had to cut it to squeeze it, but nature doesn't do it that way. It does it. Where's my model? I had it at one point. Let me see.
Please take your time.
Here's the problem. As you can see, there all these models all over the place. Oh, God. I don't know. Maybe I'm not going to be able to locate it really quick. But
That's all right.
at any rate, it's too bad because it's really an important, actually important model. I can't believe it isn't right here.
Folks, I'm going to ask.
It isn't, but what happens is instead of that string, the pink string that condensed, you take the string without cutting it and you just squeeze it together and you get a version of this. You get one of those loops here that's on the loop. And I don't have it, but let me show you this. This is a hydrogen atom that Joe Clinton and I spent 3 days making. This has got to be done on a computer. This is much too laborious to build these things. But this has so much energy that it's breaking apart. It's these sticks, these dowels I got in here are just being snapped by the energy. So you got a loop of energy, and you've got to find a way to induce energy into that. And you do that by twisting it. And the fact that nature is not just one loop, nature is always chiral. It always have right and left. It always has clockwise and counterclockwise motions that these things exhibit. And interestingly, you can't discern which is clockwise and which is not clockwise or counterclockwise until you condense it into this form. And now you can plainly see that how this is rotating and how this is rotating. So the problem is, how do you get energy into a loop? And I've just described, you bend it and you condense it. And you lock it in its condensed form to make reality, physical reality, by doing 3 different loops and putting it together to create this polyhedron here, or whatever it is, whatever polyhedron you get. So that, in a nutshell, that's what we're doing.
Wonderful. So folks, I'm going to now ask people who are very, very familiar with Buckminster Fuller's work to ask any questions that they may have. I'm going to ask one last question here. I'm very big on, working on various models myself as a way of doing things, so I've been using, tetrahedral models of various kinds, and I'm very eager to make these loops. What material do you use? If I wanted to make a tetrahedron using these loops, what would I use?
Well, a good hardware store has these loops. They're used in refrigerators, for instance, for transferring liquids and things. And get one that's got some stability to it, not a lumpy thing. And I've been told I need to make a video of how you make one of these things.
Yes.
But the simple way to make a tetrastructure is to take your 6 sticks and where they intersect at these points, you put a rubber band around here. And you rubber band all these together. So now you've got 6 sticks that are in a tetrahedron shape. Then you get your loops
Mhm.
and you plug them in either clockwise
Mhm.
or counterclockwise, but make sure
Wonderful.
they're all the same. That's the
Yeah.
trick. If
Okay.
one is out, the whole thing decays.
All right. Wonderful. Wonderful. All right, folks. So now anybody who's really familiar with Buckminster Fuller's work is welcome to take type an exclamation mark or raise your hand in Zoom to ask questions. Let's see who would like to go. John, did you have a question about tetrahedrons? I know you're very familiar with tetrahedrons. Can you, would you like to ask any question about, these loops making the tetrahedron? Go ahead.
Yeah, that was really fascinating. Thank you. I want to make an observation first and then a question. So the key thing I notice about tetrahedrons is we usually think of them flat like this. So we don't see the symmetry, the threefold symmetry. As soon as you turn it up on its edge, you have opposite edges. And I was noticing that the loops were always going through, these are at right angles, these two edges, top and bottom. And you can rotate this and get two different at right angles. So of course the six edges, and they map up in three pairs. And I noticed that that's how you always did a loop from one angle around to the opposite angle.
Twisted 90 degrees.
At the 90-degree angle. But my question is, can you make the tetrahedron with three separate loops, or do you have to break the loops in order to interlock them?
Yes, you have to do that because you're using materials, but nature using electromagnetic energy doesn't have to do that, because electromagnetic energy can pass through itself without interference, but something that's material can't. So
Right.
These static models, you have to do that. Yeah.
And my other question around the electromagnetic energy is that like that can be at all kinds of different frequencies. Is there a, or am I misunderstanding electromagnetic energy? Is it always a particular, always the same? So is there a difference between a high energy loop and a low energy loop?
Yes, there is, very much so. And spectrum analysis is the way we study that. You have a light spectrum, and then the light coming from any element will have shadow lines in it. And those are the frequencies that element needs to survive. And those shadow lines are the loop. So like hydrogen has 3 lines, 3 loops, and more, and iron has 50 some, so each one is a certain frequency. That means there's a loop that has that number of twists in it. So it's a compilation of all of those loops that go to make that form. And there's a rest state. Every element has a rest state, but if you put more energy in it, the loops jump to a higher dimension, into a higher spatial volume. And it can go on up to 81 different, there are 6 different shells that those loops can be in. The 7th shell, they have so much energy, that electron can't stay there. It just flies off. And that's your radioactive material. So you're right, you can do that.
Thank you. Awesome.
Wonderful. Thank you. Thank you, John. Really appreciate the questions. Thank you. Next up is Jeannie. Jeannie, go ahead.
Thank you so much for being here, Don. And I think I remember some of this, so correct me if I'm wrong, but so a tetrahedron is either right-handed or left-handed, meaning that all 3 loops are right-handed, or all 3 loops are left-handed. But then you did show us that one model where it seems like you were having 6 loops,
Yep.
3 of each. And, you know, what is that more stable, or what is the situation with that one? And I'll throw in another question. Well, I think I actually even know the answer, but so you had said that loops want to unwind. And is it also the opposite true, that a straight line wants to become a loop, or is it almost necessarily already? Thank you.
That's both of them are really good questions, and I'll take a stab at the first one here. The question being, how come I can make a model that only has one-handedness, like this one, but I can also make a model that has both-handedness in it? What nature does is nature cloaks, so the word to use here, the handedness that is the chiral counterpart to the handedness that we can perceive. We call the handedness a real wave or real matter, but there are anti-waves in antimatter, and there's anti-gravity, and they are in the same structure, but one is in front of the other. So this, what nature does, I haven't got to that one yet. Oh yeah. What nature does is collapse the one that's inside to the nucleus. So you start with electromagnetic energy, which is right and left, and you condense one side of it. And if it's spinning clockwise, in other words, it's left-handed, it becomes an antiparticle. This is hard to explain, but when it condenses to a nucleus, it's over top of these waves here, are over top of the wave that's coming in here in the center. So we don't see the other one because it's covered up. And both are there, but it looks to us like it's only this kind of configuration. We're not seeing the other one that's in here that's collapsed to the nucleus. So a proton wave, a positron wave and an electro wave, which are together here, when the positron wave condenses, it forms, its energy goes from 1 to 1836, which is the energy of a proton, because the frequency has become greater. It's all in frequency. If you expand it back out, now it's a positron, which is the antiparticle of an electron. All right, the second question. What is it again?
It was about your axiom, basically. Loops, or I'm not sure it's an axiom. Loops want to unwind, and is the opposite also true?
Okay, that's the difference between entropy and centropy. Entropy is the desire for all matter to become untangled and not free so that it can form stasis. And that pull of entropy is pervasive. It's a law of physics that it is always acting. And unfortunately, physics considers entropy as the loss of information. It's not a loss, it's the reassembling the information into a whole. And you can reclaim that information by condensing it. And that's what centropy is all about. So centropy is nature's way of condensing energy so that we can have a material universe. And Well, the big question is, we're very familiar with how things explode and energy blows out, and we're all aware of that. We're not aware of how energy is coming together. That mechanism seems to be missing. So now we got to go look at cosmology to find that answer. And field structure theory has a whole different cosmology to explain the magnificence of the entire universe. The Big Bang theory says that all matter was generated instantly in one big explosion. That ought to send up red flags all over the place, because now the Webb telescope is blowing that thing to pieces. And if you in the news in the last 6 months, you'll see that the Big Bang theory is just it's finally being revealed as ridiculous. And so what is the method of how a universe runs? If it didn't start with an explosion, then maybe it's always been around. And yeah, things do explode, but the whole system doesn't disappear. Your tire can blow out. Doesn't mean all 4 tires blow out. I would really like to do, Shrikant, a whole presentation on cosmology, on how we end
Absolutely.
up.
Absolutely. I'm going just going to propose multiple dates for you, and I think you're onto something, and it is at the minimum, it's going to really shake up people's assumptions that will allow them to think about nature in a fresh way. So I, would love to have you now. I know that the next things available is on 30th of July or 8th of July, 30th or 6th of July. You can pick anything. You can do anything so I would love to have that. Go ahead.
Well, I'm busy until August, so anything in August seems to be open.
Sounds good. So let me do one thing. I'm going to ask you just one quick question, and then we'll go to Joe. Just want to confirm. So when you're saying that the hydrogen atom model that you showed with two tetrahedrons, you're saying there is only a single loop there?
Yeah.
Wow.
Yeah.
Wow.
You
Okay.
see, here's a basic law of chemistry. Whenever you have an interaction between one element and another, there's always the release of energy. Where's that energy? That's the loops that aren't needed.
Wow. Wow. Well, can you hold that up again, the hydrogen atom? Wow. Okay. Yeah, let's put it in the middle. I want to make sure. Can you move it a little bit back so that the whole is shown? Okay. Very good. Very good. And just rotate it a little bit. Yeah, perfect. Perfect. Okay. All right. So we can, people who are watching the video can see it, how it is put together.
Yeah,
Thank you. Next up is going to be Joe. And then now anybody who has questions is welcome to ask by typing an exclamation mark. Joe, go ahead.
Thank you, Don. And thank you again for presenting this evening. This is pretty mind-blowing. So it's something that, yes, I'll have to go back and really try and to digest. But so one of the things that I'm trying to do is maybe compare it and contrast a little bit. I know this is a completely different different way of thinking, but how does this relate to the jitterbug and the way energy travels? That's kind of like, I'm trying to see how the loops are different, a way of looking at energy from that perspective.
Yeah, Joe Clinton and I have talked about this a lot. His Kirill jitterbug, do you know about that one that he's created? It has right and left-handedness twist to it. It's not just one-handed twist, it's right and left-handed. He has a Vimeo thing on this that you can see. But what happens is you're introducing energy by twisting. You can't pull this thing apart. The only way to get it to expand from tetrahedron to octahedron and on is by twisting. And Gary Doskis has done a lot with animating this on a computer. But what's happening is you're not destroying the structure. You're adding energy to release the inherent properties that are embedded in that structure. So the twist always involves a greater expansion of the spatial form that it has. And each one gets bigger and bigger as it unfolds itself out. And this is a beautiful example of how an atom accommodates new energy. You know, each motion or each form that it takes and its progression changes the frequency of the wave of the elements in there. And that frequency is where those lines on the spectrum of an element lie. So, you know, you start with hydrogen in its ground state and then add energy to it, and it pops up another line over here because the form is growing. The jitterbug is absolutely a great model to understand how energy affects form and does it without any destructive means. It's a very organic process. The thing with CERN over there and this collider is they're just smashing stuff together, you know, and they're not looking at the way an organic mechanism actually works to develop different forms. I just, you know, somehow that hasn't dawned on people. I mean, how does a plant with just a little pot of dirt grow these magnificent forms? It's all the allocation of energy into different structures that the wisdom, the DNA of that form is able to say, well, I want you to do this and this and this, and we get a plant, you know.
Let me ask, Joe, did you have a quick follow-up?
Go ahead and ask yours.
Okay, thanks. All right. So, Don, what I want to do is I want to look at kind of the foundational questions here. Again, my ability to do that is very limited, but I want to do that because it's really, you know, I know that you've been working on it for a long period of time. Okay, but I'm coming to it new. This is the first time I'm looking at it. And I'm saying that, look, this is a fundamentally, it is a Copernican revolution. You know, it is just turning everything upside down. You know, the world is upside down or right side up.
How about right side up?
Exactly. So I just want to focus on that, you know, this kind of very large issues, and then we can go into applications later on. So I want to kind of build up the context a little bit more on this. You made a very intriguing comment when we were talking, you know, before this video began, and you said that your experience with the Bhagavad Gita and the practice of meditation and Raja Yoga helped you with this. So can you elaborate on that, the connections between that and this?
Very much so. The first time I ever presented this was up at Joe Belt's Oswego University. And this was really interesting. I had all my models there. And I said, as a way of a disclaimer or being transparent, I want to tell you that I've spent more time in metaphysics than I have in physics. But I'm not going to go into metaphysics because I've heard people don't want to hear it. And then somebody raised their hand and says, well, I'd like to hear it. And I said, well, how many in this room would like to hear that? Every hand went up and it blew my mind. I thought, wait a minute, I've got the wrong attitude here. So the thing that is so important about metaphysics and meditation that I never realized until I got to India was that their whole practice, all the things that they do, just common, mundane, ordinary things to full-blown meditations, is stop objectifying the world and let the world be your gestalt. Let the world tell you what's going on. And by working with all the mind imagery and all that kind of stuff, it just completely opaques what's really there. And I saw that as exactly the problem that I'm having in structural physics, is I'm too concerned about the polyhedra geometries. And I haven't stepped back to see the field properties. And when I started looking at these structures as fields and not as forms, and it just everything started falling into place over those years. So that's why India was absolutely of value. And I just hope it never loses that tradition as it occidentalizes with all this stuff that's going on. It's just so important.
Wonderful. Let me pursue along the same lines. We are a group where, if somebody says, if somebody says metaphysical, do you want to say metaphysical in addition to physical? Everybody's hand is going to go up. Actually, Joe had a fantastic presentation on the relationship between metaphysical and physical.
Yes, he did.
In Bucky. And Bucky was very big. He went back and forth between metaphysical and physical. So, but that approach is very different from modern approach. Both in ancient mathematics, in Euclidean mathematics, as well as modern things. It's like they think it's odd. It's like two separate things. But why are you talking about them together? Bucky did that all the time. Joe Clinton, talked about it about it. Talk a little bit about metaphysics and physics and how it applies here.
Well, there's a simple model that I use, and let me find it here. Well, I got a more complicated one, but when you see this,
Mm-hmm.
this knot is, this is the way the Westerners approach the problem. They take a string with ends and they say, all right, this is life. That knot is life. And this knot can move along this lifetime. Move it along, move it along, move it along, move it along, move it along. And suddenly, you're dead. So what happened to you, the knot? Eastern metaphysics says it's not a string like this. It's a string like this, a loop. And you can't take the knot off the loop. But what you can do is deploy it over the whole loop. And that's the same thing as this.
Wow.
So this I call, I don't like the word death. This I call the deployed you. Or me. And this is the condensed me who's talking to you right now. And so it takes the sting of what death is about completely off the picture. And meditation is the way to sit there and say, okay, I'm a knot, but I'm also a string.
Mm-hmm.
And let me experience stringness for a change and see what I get. And so I love this model. It allows me to move between life and death without fear.
Yeah, no, I love it because this is, the principle, Yogeshwar, who did Gita meetups, use the idea of the drop and the ocean. Ocean is Brahma, yeah. And you are actually Atma, which is actually a drop. And once you realize that, then you basically, you fall into the ocean and you become the ocean and the ocean becomes you. And there is, you see this, the same kind of thing. So the point that you're making is that any structure that explains nature has to be scalable. It has to be able to go at the largest scale and the smallest scale. Yes. Now there are several things, several interesting things that you said. I wanted to highlight some of them and ask questions. Why Tometry? Why TO at the beginning?
Why? I didn't catch that.
Why do you call this new geometry Tometry?
Why?
Yeah.
Well, it's a new topology that embraces skew. Things don't intersect; they interact. It embraces the fractal aspect of reality, that a form at this size can be iterated up or iterated down, and the form remains the same. It just becomes more complex or less. So it's incorporating all of those different things that we now realize are going on that geometry just never got involved with. And searching for a new name, I just settled on Tometry.
So TO, you originally picked the TO for topology, or?
Yeah, the T. Let's see. Let me get this down. Yeah, the TO is. I like totality.
Totality. Okay.
Yeah.
Got it. Wonderful. Next one was about you in passing mentioned multiple certainty principle. Can you talk a little bit about that?
Great. That's one of my favorite subjects. It's the whole chapter of the book. We actually spend all of our time in a multiple certainty situation. I'm a father, I'm a grandfather, I'm a husband, I'm a citizen. I got so many multiple certainties that it occupies my day from start to finish. But each one has its appropriate attention in different ways. And if I'm having dinner, I'm at the table. If I'm going to bed, I'm in the bed. So I have all of these and they're all certainties, but there's a lot of them. So it's a multiple certainty. Now, in applying this to physics, we have, the question is, where's the electron? And the electron is here. Where these three forms are interacting is where you're going to get an electron. And every polyhedra has a different number of these vertices and a different number of places you can find the electron. So you no longer have to consider the electron as a cloud where you don't know where anything is. And the only way you can deal with that is through probabilities. And this is what science has settled on. Well, we don't know where anything is, but we do know there's a probability it's more likely here at this dimension from the nucleus, or here, but it's unlikely in between. That is the best they can do. But if you have a structural model of where these circuits of energy are, you know exactly where those points are if you know the polyhedra that's commanding it and the number of loops that are involved in that organization. I have models up here that model 3 different shells. And so if you count the loops and count the polyhedra, then you know the two things that science struggled to know at the micro scale, but never could. And that is where something is, position, and what its energy is, momentum. And the uncertainty principle says you can't know both. If you want to know the position, you got to stop it. So now you don't know what the momentum is. And if you want to know the momentum, then forget about position because it's all over the place. With this, we know where it is. And so this is the multi-certainty principle. It's a new form of determinism
Mhm.
It's determinism not based on just one idea where something is. It's know the energy and you know where all this energy can be found. And that's the way we live our lives.
Wonderful. Another word that you used, I'm going to just highlight one more thing, and then I think one person, DLG has a question. The one word that you used, I think that was really fundamental to what I see as your approach to things is holism. You know, you're starting with the whole, and you're always going back to the whole. So like, even when you're talking about your relations, you're saying, I have family relations, that's one loop. And then there is another loop of my work, another loop of my, you know, citizenship, and they are all interacting with one another. They are not separate from each other. You know, most modern people think in a linear way. It's like a billiard ball model. And this is a very rich interaction of continual. So there are several things about it. It's a continual loop. You know, your family situation keeps happening and your work situation keeps happening. And they all are, you know, connecting to each other, are putting, are interacting
They
with
all
each other.
form structure. If you're
And-
going to have holism in your life, you've got to balance all those energies. You got to find the structure where you can handle this, you know, and if there's too much energy, all right, get rid of that thing and settle into what you can manage. That's a problem I have. I think we all have, but the holism principle is elusive in the Occidental context because the partism, I call it partism, is dominant. And we think we spend all of our time thinking of the parts. And if you look at the dictionary for structure, it says parts make a whole. And if you go to metaphysics, you go to India and says the whole is one and the whole makes the parts. That's holism. And East, Occidental and Oriental traditions have been inexplicable to each other because of this way of dealing with reality, partism versus holism. In India, the thing that's of value with the people I was hanging out with is what's the holism? They're not going around saying, well, what's the parts here? I got to have all these parts before I'm happy. That's not a concept I find.
Yes.
Or
No, absolutely. I mean, Don, at 52 Living Ideas, we studied, Bhagavad Gita, Tao Te Ching, and Gospel of John. We are now studying Seneca. What interesting thing is that if you go back, I think it's not just, it is absolutely true what you're saying about India, but I think it is true of a different time. So this is a time before printing, when the older cultures, when you look at the axial age, like the way in which Tao Te Ching, Lao Tzu puts it, is that it's the Tao. You are focused on 10,000 things. The Tao has produced 10,000 things, and you're just focused on those 10,000 things, and you have missed the Tao. It's the same way. The way in which, Bhagavad Gita talks about it is don't get attached to the periphery, focus on the center. The way in which the Bible puts it is don't focus on the fruit, focus on the true vine and the root from which it is coming. If you take the fruit, you are missing the mark and you're going to not have actual fruit. You're going to actually cause destruction. You need to focus on the vine of how things are growing and where they are coming from. So Seneca is all focused on the universal principles. He's saying the idea of cosmopolitan, look for things that are true, universal for everybody, and use that as a base for action. All of these four traditions are holistic traditions. It's in modern times, what has happened is that the Humpty Dumpty has fallen down. And we think we can put it back together by putting parts together and make but it can't be done with all king's men,
Well, when we first started this, my wife and I was going on about the Occident does this and that and the other thing. And I noticed that there wasn't a verb form of Occident. There's a noun, but with Orient, there is a verb form. And I thought, well, Occident needs a verb form for what it does. So we came up with a definition of orientation means putting yourself in relation to totality. And Occidenting means taking totality to work for you. In other words, we want to manipulate reality and change it to better suit us. So all this stuff that we're bringing into our lives, all the technology and everything, what is it doing? It's controlling and bringing in and harnessing all the potentials of this natural world. And the yogi sits in his meditation and says, I don't want to be confused by all of this stuff. I want to experience totality. And I once asked this Vedanta sage at the ashram, I said, why is it that with all the sublime philosophy, there are beggars on the street out there, and he says, well, look, we only have maybe 30 or 40 years on this planet. Now, are you going to be involved with all the trivialities for 40 years? Or are you going to try to experience what the whole of it is? And I said, wow, that's the point.
Mm-hmm.
But we ended up leaving. We had this decision to make. Do we leave India or do we stay there? And it turned out I decided to leave, and because I just felt to do what I initially wanted to do, which is understand how this cosmos is structured. I had to understand it metaphysically as well as physically. And I hadn't done a good enough job with the Occidental part. And the Oriental part was just given to me so wonderfully by these people I was living with, that I felt, well, maybe I have enough courage to face the West again.
Wonderful, wonderful. Thank you. Let's. I think DLG has a question. DLG, go ahead.
Yeah, well, actually, you asked it already. It was one of your questions. I know I know the Greek root of geo, but I was struggling with what was the Greek root of to. So you answered that question. Thank you. But since I have the floor, I do want to say you have a beautiful mind, sir, and I am in awe. That's really amazing stuff. Thank you very much.
Thank you, DLG. You said what I wanted to say.
If you're complimenting the universe, not me.
Yes. No, exactly. And I mean, that is the attitude that produces everything. That is the attitude of the yogi. We had, we studied Jnaneshwar, who is like founder of the language that I grew up speaking, Marathi. He's a contemporary of Aquinas, and he starts his commentary on Gita by saying that, look, I'm only a child, in complete awe of what I'm talking about. I can barely babble. Okay, that's all I can do because what I'm talking about is so great.
Yeah, that's true.
That core of what I'm talking about is within you. So please listen to what I'm saying and then refer to what it is within you, correct whatever mistakes I'm making, add whatever things I'm missing, because you too have God within you. So that is the attitude. And then he goes on to summarize entire core of Gita in one sentence. So after saying all of this, that's what he calls babbling. So that is the standard, in Aquinas at the end of his life, he was asked about his thoughts on Trinity. And of course, he has written, he's considered to be, the giant. But his thing was that this is all chaff. But that is the right attitude. It's the attitude of understanding. You're standing under nature and you're trying to understand it.
Yeah.
All right, thank you. Thank you, DLJ. All right, folks. So Don, I would love to have you back as many times as you want. We'll come up with a thing. What I want to do more than anything else is to make the foundation of what you're saying more accessible to more people. Because if they get the foundation, then they will go into other things. Now I'm going to, go to Jeannie, and then would love to hear what people got, because I want people to, comment on what they got from this meetup, from this presentation. We're going to start with Jeannie. Jeannie, go ahead.
Well, I just wanted to mention there were some questions in chat that might be addressed.
No, that's fine. If anybody wants to ask any questions, they can go ahead and raise it. Thank you. So
They're already in chat.
understand.
Oh.
Thank you. No, I'm aware of that. I went through all of those, and then what I'm trying to do is that I'm trying to focus on the audience of the YouTube, and I'm focused on everybody. I'm saying, in order to make this topic accessible to everybody, what questions should be asked, if any? So that's why I do a little bit of selectivity to make sure, because otherwise, so that's the reason I have some selectivity.
Well, some of them were about being condensed, and
Sure,
I would
please
like
go
you
ahead.
to address that, perhaps.
Please go ahead. Actually, that's a great question. You showed two models. There are so much stuff you said, Don. So there is just only few things we've been able to follow up with. So you showed two models, your model and the model by Joe Clinton, and you called one of them condensed, and other one I don't remember what you called. Can you explain those two terms and talk about why those models are, why you call one of them condensed and one of them by another term?
Yes, the two primary forces, or the two primary things that nature is doing, is either condensing or deploying. And energy is that motion from condense to deploy, but also from deploy to condense. That's where energy is. And so a condensed state is one where, I haven't talked very much about the plenum, but that is a fundamental concept in the book I'm writing right now. It's just solid full of this information about the plenum, which is totality. In Hindi, it's called akasha. And in that is energy called Shakti. But Shakti can form what is called gruntis, or knots in Sanskrit. And so, there's the relationship. The plenum is an absolute. And that's a difficult concept for physics to embrace. They battle that one. But there's been experiments where what's happening appears to be an absolute, not in the relative domain. I could go into that, but and another thing we haven't talked about is, what's the role of consciousness in all of this? So we have this plenum that's an absolute energy matrix, and it has structure. It is basically tetrahedral. And that tetrahedral quality is what gives forms at the macro scale, the TNT triangle and tetrahedron gives it that stability. And that stability is because in a field, if anything moves, everything else moves too. You can't move something and nothing else happens. That's what happens when a field deteriorates. It'll fall apart. So something is working on the plenum or the akasha to precipitate out a condensed form of it, we call matter. And the only thing that could do that is consciousness. And this is a totally known process in Vedantic. It's called Prakriti and Purusha. Purusha is consciousness and Prakriti is the stuff of consciousness. And it's the interaction of those two that create this universe. Now, the physics looks at that and they don't have any use for that idea, but because they say, well, look, my consciousness can't make this table move across the room. So consciousness is not a factor in the shape of the universe. But if you go down to the Planck level, you go so far down, and there's a beautiful model for what happens, and you can find it on YouTube. Some guy took a tiny little sugar cube, maybe so big, and put it next to one that was a little bit bigger, next to one a little bit bigger, bigger, till this monstrous sugar cube was at the end of it, and he just touched that little one, and that fell onto the other one, and the whole thing comes down. Now, I think that's what's going on at the substratum of our universe, down at the level of Planck's constant, is it takes ever so little amount of energy, if you want to call it, or will, to initiate a process that will eventually turn up here at the macro scale as a form, an event, an action. And to say that consciousness doesn't work means you no longer have any mechanism for creating a universe. You can have all the energy in the world, all the energy in the universe, but if you don't have a mechanism to initiate an action, nothing's going to happen. And consciousness is that subtle and pervasive. Prakriti and Purusha. I mean, these Vedic guys had this down, man. They just totally knew how this was working.
Wow. So what I'm going to do, Don, is I'm going to send you a translation I did by Naneshwar's. Naneshwar is this very beautiful presentation on Purusha and Prakriti. He calls it Shiva Shakti. So it's like Shiva and Shakti and their interaction. And it's just beautiful poetry, but it captures all these principles better than I've ever seen. So I'll send that to you. Next up is going to be Joe. Joe, go ahead.
Yeah, you asked about like what we got out of this evening, and so I just wanted to follow up on that. And I was, first say thank you again for the presentation, and it is a lot to take in, but I think that it could give me a new way of kind of looking at the world. And so at the same time, you're actually still giving me insights to the way the world is being seen now. So that's something like the way thinking about even uncertainty and how we how position and momentum actually are related to one another, in the sense that and how physics is seen today, and then how you're looking at it differently. It's a lot to take in, but it's really interesting and exciting as well. So I also very much appreciated how you related it to philosophical traditions. That was especially insightful. So I look forward to watching this again.
Thank you, Joe. Thank you, folks. would love to hear what you got from the presentation, what you thought of it. Go ahead and type an exclamation mark. I want to disagree with Joe on one thing. You said it's a lot to take in. I think more fundamentally, it's a lot to take out. There is a lot of things you need to subtract. And that is actually far more fundamental, because so much of thinking that we have in this space is built on those this entire plethora of concepts, ideas, and taking that out is really what is going to create space for engaging with nature. So thank you. Next up, anybody wants to comment on what they got from the presentation, and then we will close up. And I'm going to have, we're going to have Don back, and we'll figure out how to proceed from it, so that all of this remains accessible. Okay, if nobody else has anything, so Don, I think this is one of the great, we have done about 1,500 meetups, Don. And this is definitely in the top 1%, if not, if not more. So really, I mean, it's a fundamental way of looking at things, and would love to have you back. I mean, the thing is that we are, we are a very patient, we are, this is a community of explorers, community of people who are trying to understand things. And go ahead.
I just want to thank everybody here for sticking around for this. I mean, this is almost 2 hours or maybe more, and I love talking about it. So it's to me, I really enjoy this.
Yeah, and what I want to say is that the really fascinating thing to me is that this is exactly what we've been doing. What we've been doing is we've been going back to these older traditions in axial age in India, China, and the West, and seeing that there is a way of thinking which puts whole first. And those ways of thinking, saying that if you do not have a whole, you have actually nothing. Okay, yeah. you can just take your marbles and go home. Okay, because those are just parts. Okay, these marbles are just parts. You're playing around with them. You think that this is billiard balls game that you're playing, but no, you're not ready to play yet. Okay, but it is really refreshing to see it being applied to things like physics, and to geometry, mathematics and geometry, which are traditionally the strengths of the West. So thank you so much, and really look forward to. Jeannie, you had something to say. Go ahead.
Just thank you so much, Don. So nice to see you again.
Thank you, Jeannie.
Wonderful. All right, see you folks. Bye.
And I want to compliment Joe with his girl with a pearl.
Yes. Yes.
Thank you so much.
Wonderful.
She's my favorite.
He's a great painter,
Yeah. She keeps me company, so I need somebody to.
Wonderful. See you. Bye.